it's Anya. Today I'll be going over how different ideas from this chapter can be applied to real-life situations, specifically the concepts of exponential and logarithmic functions. Let's get started. So a population of ants has a growth rate of 10% every year. If the starting population is 29,000 ants, how many years will it be until the population is 385,999? How large will the population be after 10 years? Alright, so the first part of the question gives us enough information to construct an equation for this situation. So we're going to have to use an exponential function. So let's first identify our principal amount. Our starting population is 29,000 ants. So our principal amount would be 29,000. Then we're going to identify our growth rate or decay rate. This is a growth rate of 10%, so we're going to do 1 plus rather than 1 minus, and it will be 0.1 since it's growing by 10%, and this will be to the x power. So our x variable stands for the years passed since the starting population was measured. And then we are going to set that equal to y, which would be the population at each point in time. Alright, so the first part of the question is asking how many years it will be until the population is 385,999. So we actually know our y value at this point in time, and we have to figure out the x value. So let's set up our equation for that. 29,000 1.1 x equals 385,999. So the first thing we can do is just try and isolate our x variable. So we do that by dividing each side by 29,000. So on the left side, we'll just take out this, and then on the right side, going to be equal to about 1.331. Let's say that. Alright, so now we have to figure out what x is. From this point, we can't really do anything, so we have to convert it into a log function. So it would be log, and then our base is 1.1, our answer is 1.331, and our answer is x. So now we finally isolated our x variable. So now we can solve for this equation in our calculator, and we get x equals 3. So after 3 years, the population would be 385,999. So at this point in the equation, we'd be kind of stuck there. Sometimes we have something like 2x equals 8, and then we know 2 to the x power is equal to 2 to the thirds, but this is kind of an obscure number, so we wouldn't necessarily know that 1.1 to the third is equal to 1.331. So we'd have to use the log function and our calculators to figure that out. Alright, next part of the question. How large will the population be after 10 years? Okay, so we can go back to our initial equation, 29,000, 1.1, and this time we're going to substitute in 10 for x, since we're now solving for the population y. So we can just substitute that right into our calculators. And then the answer comes out to 75218.53. We'll end it there. So we always have to have whole numbers when we're talking about populations, so we're going to round that to about 75,219 ants after 2 years. So yeah, exponential functions are a great way to learn more about populations, whether that be wildlife or actual human populations, and not only just this topic, exponential functions and logarithmic functions too can be applied to so many different scenarios. Alright, thank you for listening.